And if you already did them, then just go to the next topic. A little bit more sized this so that we can see what's going on. So here is the thought of this is to have this in a bit more simple form. Just to practice this, how you can actually modify these equations. This is just some kind of mathematical language interpretation. So then we would need to use this kind of dependency. The quadratic equation. If you solve it and you find the roots, then you can rewrite the expression, this expression as like this. This is what we are aiming for here. So I will write it here with another. I only have now this color with me. So from technical formulas I can find from page 9, second order equation. And it says that, first of all, the roots I can get with this kind of a dependence. So I have to have it in this form, everything on the other side and the 0 on the other. From there, I can figure out the roots. And from there, I can rewrite this expression. So I know also from the technical formulas this kind of a dependency. This is the same as a times x minus x1 times x minus x2. And this is what I'm aiming for here. So both of these expressions I would rewrite like this. So I first solve them. and then I rewrite them. This is also the same thing as you can see that's been done here in this solution already, but I will still calculate it here and you can calculate it yourselves. Do you know what to do? Yes? Yes. Okay. So I will take first this, the numerator, denominator. I don't know which one was which. Just the upper part. I mark it as 0. So just like that. And I put it to this form of solving it. It needs to be 4 times 2. It becomes a positive sign because there's 2 minuses. So I actually get square root of 9. And I get -12 plus -3 divided by 2, from which I would get the roots plus 3 divided by 2 and -12 -3 divided by 2. This would obviously be 1, 2 divided by 2, and this would be -4 divided by 2, which would be -2. Yes. Does this seem very clear to you at this point? Do you know how to solve these equations with your calculator as well? You can also now, from now on, then you can just solve them but not in the exam. In the exam, you still have to show that you can actually, I'm able to do this, and then since then, just with the calculator. Or even Excel. I haven't done this with the Excel ever. Okay, then I'll rewrite this. I'll just put it down here so this x plus 2 minus is, so a is obviously 1. There's no, so then I can just put the roots there. X minus 1 and x plus 2, yeah? Looks like that. That was my first equation, and then I modify the next. So the down part of this. And I know from here that 4 plus minus 4 times 2 times minus 1 divided by 2 times 2. Mm, 2 plus minus 4, and then it's plus 8. Oops, it's a bit long. And divided by 4. Yes, by 4. This is also 4, obviously, not 2. Obviously, the calculator would be more accurate. So then I get, I'll check if I'm doing this correctly. This is something different. I have here 1 and here I have 16. This is not even the same. Whatever. I'll get something different. Is this, I wonder if this is supposed to be 16. Because now I'm supposed to get some kind of even roots. Well, it doesn't look like maybe that's gonna happen here. Then I'll just take there another number so I get some even roots. Yeah. So if I have 16 plus 8, that's 24. But that's not, this doesn't now go even. Okay. Do you mind if I do a little modification here? Because if there is 16, then I get some even roots and then I get to some kind of a solution. Sorry about this, but now I have to do something. This will be 16. Just like that. Okay. So then this would be 16. Nothing bad happened. I just changed the number. Oops. So then I get something different here, obviously. Some a bit bigger number. And I already take my calculator. So I would have 4 times 2 times 16, which would be 128. So I would have had here 8 plus 128. Oh. So plus 8. Yeah, well, I can obviously calculate, but let's see then if this is even. No. Am I still doing something wrong? This is that. No. Yes. No problem. Still, I need. I had written something wrong here. Obviously, this is a lot better to do with the calculator. This is waste of time. Anyhow, let's do this. We still learned it. That also a teacher can do wants to get something and still no. What am I supposed to get from here? Four times 2 times minus 16. Yeah, I'm supposed to get. No. There's a wrong sign. Don't ever calculate this by hand. Again. Like that. No? Why don't I get this now? To what I want. Because I have the 128. Okay, let's try once more. Mm-hmm. 4. And then there's 8. No, and not 128. Let's put the 16 back. I didn't calculate it yet. Plus. Oops. Plus 8 times 16. Yes. Finally. Well. Okay, now this goes even. So x is 1 plus minus 3. Okay, let's put it 1 plus 3 and 1 minus 3. Plus and 1 minus 3. Which is 4 or minus 2. This is what I want anyway. So then I can rewrite here that this expression minus 16. So this was minus 16 now. Is there's the multiplier, and then there would be x minus 4 and x plus 2, which is great that I got the x plus 2, because then I can rewrite again this one. For sure, if you were in the high school, you did something like this a lot. Maybe, at least I remember doing it. I still remember it. This is now the upper part. Numerator, maybe, called. And then the down part. And now I've got the result that I wanted. Why did I want this result? Because I can kill those, yes? And then I get, and all this trouble for this kind of, why would anybody want to do something like this? Well, we did it once. We will actually come back to this once on 1 week next spring. But only 1 week where we need to do something like this again. Okay, I can still rewrite it. X minus 1 and 2x minus 8, for example, as well. I think I got to the correct. Yes, it looks good. So I managed to do a really big deed here today in my engineering studies, and I managed to modify this kind of expression. Into this. How would I ever have known if I wouldn't have went through all that trouble? What a big and great result that was. Okay. At least now I know something that this kind of a thingy goes into this kind of a thingy. And sometimes it's easier and sometimes it's more difficult. If you are gaining for a certain result, then you might have to have do a bit more troublesome procedure. Okay, I think we already calculated the 7, A or something, B or. Yes, we calculated 7A. Maybe I can do the B after. Here it doesn't look that bad because you can just take some common multipliers. Oh, no, yeah, these are pretty easy to do. Okay, so obviously I can modify, for example, this down part with this. There was the dependency. This dependency here. Which dependency is it? Because there's a minus. Yeah. This dependency. This one. There. And then I know that this is like this. And I know that I have this kind of a dependency here. That. And then I just modify that. There was the tree. And that looks now like plus y, and they have the second power x minus y, and they both have the second power as well. Great. And then it looks like I need something like that here to get rid of it, yes. So I have there this and this. Yes, so I can take Or can I still do something different as well? Okay, let's take a common multiplier anyway. So there would be y's and x's. Yeah, I think I actually get it there now. Yes. So, well, for example, here I can put 2 and there's always x and there's always y. And if I multiply that with 2xy, I get x in the power of 2. And then if I multiply this with 2xy, I get, you know, y in the power of 2. Yes. Starts to look good. That was the thing that I could get rid of. And now it looks like I can just kill it. Yes. And then I get something that looks different. A bit different. A bit more maybe simple here. Wow. Amazing. I think this was what I was supposed to get as well. Oh yeah, and then I can still put it in this form as well. Why not? Why not? So I know again this dependency here, so I can again modify this. Can also look a bit different. Oops. And then I have one more to go. So I'm dividing something with something. Okay, this starts to look good because there's 2 similar things there. Now I just have to modify, I have to remove this and then I have to multiply, yeah? Because I know that, did I have that kind of a rule here? No, I don't think, maybe here. Whereas I know that because this is a fraction, if I divide with a fraction, I can multiply with the inverse number or inverse number, basically. So I just flipped it around. And this, of course, then means that I have these all on the same line. And here I have the same thing. I could also modify it more, or maybe I don't, because I can already take it out. I don't have to do anything more with it. And then I get, and then I can still do something here because here is x everywhere. So I can take this down part to look like this so that I'm multiplying with the x. And then I can still kill the x. Yeah. And then I just get 1 divided by this kind of a... Okay. Wow. Okay, so do you want to what do you want to do? Do you want to go to the next thing? This blah blah blah. Or do you want to... So it's the forming an expression and just try to form an expression of sentences that are here. Or would you rather derive the second degree? This. Does it make any difference to do that? Which one should we do first? Or should we just skip the deriving the equation? For sure, somebody who was in high school did it, yeah? You have...
Mä oon tehnyt tämän koko kurssin varmaan lukiossa.
Niin oot.
Siis mä en oikeastaan seuraa tätä, niin ei kannata kysyä multa.
Niinpä. Ja ehkä muutkin on tehneet samantyyppistä jossain. Other people have done something similar somewhere, but I don't know how much. Yeah. Which one should we do? Maybe we just start this forming an expression thing now, and then we can do this second degree equation derivation at some point if we do it. Or if we don't, then we don't. Okay. It might be of interest if you're interested in doing that kind of whatever. How do you say? Mathematical tricks a bit or something. What you can do with these rules that we just learned here. So then you can like sort of realize how that's formed. But it's not like maybe not that important. So these ones, the first ones here are just simple calculations. Well, yeah, you just have to take like a root. And then you have to maybe think a bit after. Okay. So obviously here you don't have to form any kinds of expressions or equations. You just can just solve this. And it's of course pretty simple. You just and then I want to take the basically the third rule. Maybe this is just to realize that you can maybe we did something similar already. Third rule. That's the accurate form, and then you can also have it in the form of like this. And then you get something out of there. And it's also the same as this in the power of 1/3. If it happened that you couldn't take this kind of whatever roots, then you can also put the 25 in the power of 1/3, which is of course the same. Okay, maybe I'll let you to think a bit. Don't go so fast. Going on. Yeah, but it doesn't matter because it's not. I don't know why it says that, to be honest. Maybe there's some tab that I should be know how to click. But I just, now you can, yes, I see that, I did this. Yeah, so it's a big, it's Kontinkankaan, it's the same, it's the other that's in Oulu as well. Obviously, you can do it in many places, yes. Because when I put the exam there, I can't even fit anything, so I never even see that on the front. So it looks like then it's taken until Wednesday. And then you can take fines, obviously it's booked until that. And you have to know when you go there that you can't change many things that you, I think maybe there's even some lockers. So you can just put everything there and then only the things that you need, for example, the cell phone you can't have. Yeah. It's forbidden. But I think it says quite clearly there. Yes. Does it say on the door or something, all the things that are forbidden? I only took my things and calculator and the technical forms. Yes. Good. Because there has been a couple of problems with that. Some people went there with all the clothes and the phones and everything, and even with a friend. Which is not funny, but it's even funny because it's so absurd. But I think it says quite clearly on the door what you are not allowed to take with you. Don't take your, maybe it doesn't say that don't take your friend or don't take your dog, but you should know that, sort of, or even your kid. So answer. No need to have to pay there is a you have to pay Okay, so in examinarium, don't take your clothes, don't take your phone. Just technical formulas, calculator, pens, maybe rubber, and you can take this. But don't take your friend, your dog, your grandma, your kid. Don't chat with somebody who is there, who you don't know. Don't say hi to the person. Otherwise, even if you would be wanted to be polite, don't be. Be a Finn. Okay. Mm. There's another slot available today. Today? Oh, yeah, Wednesday. Actually, it was Monday. I was 3 days working at home, but I thought it was still Monday. Yeah, good. So it's not, nobody wants to go there. You can go there whenever you want. Yes, that's right. Okay. So, I will continue calculating these. So what are we after here? It's similar as with the second degree equation solving, but now here is only the power 3. Oops. But I can of course take common multiplier here. because both of these terms have the x there. So there would be x power of 2 minus 100 and times x. So if I would multiply then with this, I would get this same sentence, yes. And now, if this is 0, I know that either other one of these terms has to be 0. So the other of these terms, so something like a times b is 0, so a is 0 or b is 0. This is my law here, and then I know that x is 0. Or they can both be as well. This 2x minus 100 is 0. Okay, and then I will now here I have now one solution, and then the other I will continue with. So this is then 100, and then I of course divide. $50, and then I take the root. And now I remember that I did take actually the plus minus, because here you can have a term plus or minus. You know, this x can be plus or minus, whatever, because everything in the power of 2 is always positive. So I get two solutions. And it's the plus minus. And then I can start playing with this, or then I can just take straight the answer. Plus minus, so this is 2 times 25, and 25 is 5 times 5, so I can either do 5 square root 2, or then I can just say that it's it just have done like this, which said also this 5 square root 2, because it wants to, my calculator wants to show the, let's go back, 5 square root 2. It wants to show the like most sort of simple accurate answer. And here I get then the answer which is not accurate anymore, because of course there's some endless line of decimals and some are missing. Something like that. And if I, so now I have many roots here. If I would want to draw this with GeoGebra, then I could have seen how it looked like. And I have to put it maybe this way. GeoGebra Classic. Okay, I agreed to something that I don't know what I agreed to.
This line.
Oops, what did I do? I wanted to do this. No, I'm still not doing it. Hey, what? No. minus 100. Why doesn't it look like that? Did I do something weird? Maybe I have to put here a multiplications. Oops. No, I'm doing a different one. Yes. That is actually correct, isn't it? Let's do another. This is the first one. Yeah. 2x power of 3. Now this. So I could have solved that one. Now this starts to look. Yeah. I don't have to put the multiplication sign. So it shows me the roots there. So this was my, if I now I can click like this, I can see just the first solution. It was 2 point, well, about 3. And then this. And then I can, of course, maybe zoom in a bit, but I don't know if I will get anything nice looking. How did I do this? Now the oxalate. Maybe like, oops. I didn't aim for that. It's lost my axis. Oh. I did something stupid, but it doesn't matter. Okay, I somehow managed to lose all the axes. Oh. But anyhow, I already saw that it was correct, yeah. Teacher can do everything very, very smoothly. I'll try again. For sure, you could have told me how to get the axes back. Okay, but anyhow, here I can see that this something is here going and it has 3 roots. So I got all the 3 roots, which are the 0, the -7 a bit more, and +7 a bit more. Yes? Whatever. I'm not trying to modify it anymore because it's not my day of success maybe with this kind of this is good enough result for today. Okay, so let's go back to the where we were. Where's my damn thing? Why do I have so many things open? Anyway, it's there. Next. Yeah, maybe this wants to know, tell you that, what does it want to tell you? Take the zeros out? Or just divide with the 1000? So then, this is the same. And then I would take the 10th root. Maybe if you need to take a 10th root, you face a problem with your calculator. Tenth root, whoever wants to do something like that. So then it's also 2 in the power of 1 divided by 10. Yes. So maybe this is more, maybe this is easier way of obtaining the result. Hmm. 10th root of 2. It looks like my calculator wants to do it anyway. Wow. So this one, this number, if I multiply with itself 10 times, then I get 2. Yeah, that's very interesting, isn't it? Or not? Okay, so then it's something like that. And then whatever this would be. So then I could have also done this with my calculator if this was something that I needed to do. Then I could have put it in this kind of a power. So I see if my calculator didn't want to perform this kind of operation that I did the last time. Investment. Okay, maybe this next is a bit more interesting. Do the investments nowadays grow? Oh, this is a good interest, yeah. So if I manage to, in 10 years, I have 5,000 and I have an interest percentage so that from somewhere that I have 15,000 after 10 years. That's good, yeah. Does this happen in real life? Who knows? Maybe you can find somewhere this kind of where to invest your 5 grand and but maybe it should be more than 5 grand, then suddenly you're quite rich. After 10 years, you don't have to do much. Okay, so my 5,000 euros goes to 15,000 euros. And my time is years. So I have some kind of an interest here, yeah? And it means that this is, multiplied. This grows a little bit every year, but every year the same, yeah? So this one goes, is multiplied with something. Yeah, and it becomes this. But then this thing happens 10 times. So it's multiplied 10 times. So you can put there the power 10. Yes? It makes sense. And of course, it has to be something more than one, so that when it's the interest comes growing in something, so it's always this amount plus a little bit more. There's some kind of an interest percent on top of this, and then it grows, it's multiplied with that again. So that same amount plus a little bit more, and again with the same. Same percent. And now you would just need to solve. So obviously, maybe this was aiming to this. Yeah. And this, then it would be easy to solve it. This then 15,000 divided by 5,000 might be 3. And then we would need to take again the 10th root. So in this kind of a case, you would actually need this. That doesn't seem that practical. 10th root. Or then just put it in the power of 1/10. Yes. 1/10. If you didn't manage to take the 10th root with your calculator. Oh, so let's see. Oops, I took a wrong root. Something like this multiplied 10 times and we get 3. So what is now the interest percentage? How much interest do you get? Do you find this kind of an interest person ever? Yeah, it's the one that's on top of 1. So it's always itself and then a little bit more. But now it's even like about 11.6, which is quite a lot. I remember that there used to be some kind of high interest accounts where you could put if you had money and you could put it in some kind of high interest account. I don't know if the interest was this high though. I hope there would be such accounts. Okay. Now we would need to Just form an expression. Sum of three sequential integers. How do you pronounce that? It sounds always awful when you when you say it. Sum of something, three things is 39, yes. If it says that they are sequential, it means that they have to like follow each other, yeah? So if you have one, then the next one has to be, so there's a sum and there has to be three of them. The next one has to be one greater, yes? And then the next one has to be two greater. So this would mean that they are sequential, yes? Sequence. Sequential. So, for example, one and two and three would be sequential. So then it would be one plus two plus three, so it always grows. Grows one. And from here, you can then solve x, yes? It's pretty easy. So there would be three x's, and then there would be 3. Yes. Okay, good luck. But don't go with hurdle. It is, sorry, this is it might seem as a bad joke, but that has happened as well. Yeah. And I've been even informed even twice this autumn it has happened. That somebody went there with all the equipment plus a friend.
And my friend is waiting outside the room.
Yes, I understand. Just don't go to the examining room with her. That's all I want to say. Okay, bye. Good luck. Okay, I will let you think a bit. Just Okay, this starts to look a bit more complicated to solve now. I have again the three sequential integers there. So then I just have to open up this expression. And obviously, because there's 3 times, I already get the third degree equation. So maybe this is something that I won't manage to solve now, and maybe I will solve it then in the spring when I get something introduced. So first, of course, I have to multiply these two with the x. So I multiply the first. And then I multiply the second. So I have something like this. So I just multiply these and I still have one left there. So I did this. This is how it's usually expressed. I multiplied, oops, they're both. Just like that. And then I have to do it, of course, again, but with both of the terms. So with this one, I multiply this, and with this one, I multiply this and this. Now this starts to look horrible. If I draw that one, and the next. This and this. So this first multiplies this, which is my 30-degree term. And then this one multiplies this. And then with this. And then this. 2x. And then I can still, of course, add these two. 2, 3. So this is now a third-degree equation. We haven't really solved something like this. And if I want this still in a different is 0, and then I could start. But because it's we also solved here a 30-degree equation, but this was easy because we could there it wasn't a complete. There were only the third-degree term and the first-degree term, and now it's a bit more complicated. Of course, there's if you ask it from the ChatGPT or your mathematician friend, this is also something that somebody could. Well, there's many ways of solving these things, but we don't maybe need to learn them. But we will learn one in the spring. I'll put this into the GeoGebra. And I do it in a. Let's see how it looks like. Nice. Yeah, but then I still lower it a bit. Ooh. So now it looks like it went, and then because if I have it like this, let's take that out. I have nice 3 roots there. But then when I put here this term, I can see that, okay, let's not put it yet. I can see that it goes, upwards and just like down, 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 and here up, up, up. So now I lower it I put it 504 down. So the one line that came up is this seems to be my root. I could now start solving this. I could, for example, if I would now know that the 7 is the root, I could start dividing it with this like a term that includes this root, and then I would get it into a simpler form and solve it. But why to do that? You don't need that kind of tricks here. Okay, should we go to eat? Would that be a good idea now? Are you hungry? You have still some 3D CAD. Is that nice? Is it more interesting than this?
No.
No! Oh, that's a good answer. Thank you. This is more interesting.